Hello everyone! Welcome to another episode of Science Lecture video series with Sir Geronimo. Let's get started.
Hello my dear young intellectuals! Welcome sa isa na namang makabuluhang discussion kasama ang iyong guro, si Sir Geronimo. Now, before we start our lesson for today, let us have a short review first about the different steps of scientific method. So what are the different steps in scientific method again? So let us have the first step, which is to make an observation. After that, we are going to ask a question related to what we have observed. After that, we are going to formulate a hypothesis that is a possible answer to our constructed question. Our next step will be to test the hypothesis by means of experimentation. After that, we are going to gather the data and analyze them. And after that, we are going to conclude what is the final answer to our question. And lastly, don't forget to communicate or share your result with others. So those are the 7 steps of scientific method. For today, we are just going to focus on one very crucial step in this investigation, and that is experimentation. So for our topic for today, we are going to tackle about designing an experiment. But what is an experimentation? So an experimentation is a procedure to test the hypothesis. So you have your hypothesis, which is just a tentative or possible answer to your question, but you are not yet sure. That's why you need to test it. And how are you going to test it? You need to conduct an experimentation. And in an experimentation, there must be variables similar to our lesson last time. And when we say variable, it is any factor in the experiment that is being tested. As I told you, these are the actors and actresses on your experiment because these are the variables that you manipulate, that you measure, that you keep the same. Let us have a quick recap first about the 3 types of variables. So we have the independent variable. The first type of variable is independent variable, and this is any factor that is changed or manipulated in an experiment. So meaning to say, this will cause an effect to the dependent variable. So we can say that independent variable is the cause, while the dependent variable is the factor that is being measured or observed. So we can say that the dependent variable is the factor that we are observing. So this will take the effect based on the independent variable. So we can say that the dependent variable is the effect, while the independent variable is the cause. And the last type is the control variable, which is the factor or any factor that should be kept the same or constant except from the independent variable, because the independent variable is the factor that you need to change while keeping the others the same. So I have here an illustration. So we are going to identify the independent, dependent, and controlled variables in this situation. So assuming that we are going to plant, and then we water them in terms of 3 different substances. So we have a soft drink, we have a juice, and we also have a water. So obviously, we are changing the kind of substance that we use to water these plants. So we have the same plants, we are going to measure them, but we will use different substances. So obviously, this is our independent variable, the kind of liquid or substance that will be used on each plant. That is the one thing or the factor that we manipulate. Whereas the dependent variable, which is the factor that we will measure, is obviously the plant height, because we need to identify which among the three substances will be effective enough to make the plant grow higher in terms of plant height. And for our control variable, the variables that should be the same or constant, all the factors such as the type of plant, the pot size, the amount of liquid that you will use, the soil type, and the environment itself should be the same, considering that the independent variable, which is the type of liquid, will be changing alone. So now that we have our quick recap regarding the types of variables, let us now apply them in making or in conducting our experimentation. So our experiment should contain the following. There are two groups that we need to identify for us to conduct our experiment scientifically. So we have the first group, which is the control group. The control group is the normal setup, also known as the typical setup. That is where you will not apply any factor that you want to test. On the other hand, we have the experimental group. The experimental group is the group that you're trying to manipulate. So that is the group where you are going to apply your experimental variables. So we have here an example. So in a particular experiment, there are two subgroups. We have the control group and the experimental group. If you want to test something, let's say for example, silly soda, you will test them to the experimental group. And what will happen to our control group? They will receive the normal setup. They will receive the normal soda. Okay, so if you wish to test something that has not been tested before, you test them in the experimental group. While for the control group, you are just going to give them the typical setup. Now, what is the importance of having a control group and experimental group? The importance is we need to make sure that the experimental setup will be as comparable as possible with the control group. So meaning to say, the reason why we have two groups is for comparison purposes. We need to compare which one is effective, the typical setup or the normal setup, or the experimental setup that you're trying to manipulate. Now, again, there are two parts or subgroups in a controlled experiment. We have the experimental group that contains your variable, and the control group which does not contain the variable, and it is used only for comparison. So let us have an example. On John's bread and yeast experiment, John wanted to know if the amount of yeast affects the bread, no? So typically, her grandmother or his grandmother usually use 50 grams of yeast. So we will use it as our control group because that is the typical amount of yeast that his grandmother uses while baking a bread. Now, what will be our experimental group? So obviously, our experimental group will be our experimental variables, wherein John may use either 30, 70, or 100 grams of yeast. So what can you notice? We did not include 50 grams in the experimental group because that is already tested. Therefore, it is included in our control group. What we included in our experimental group are the amounts which are not yet tested. That's why we will compare the result of these three groups with our control group, or these three amounts with our control group. Another example is the effect of biofertilizer X on plant growth. So we have two groups again because we want to test if our biofertilizer X will be effective on plant growth. So we have experimental group and we have the control group. For our experimental group, we have a plant and that is where we will apply our biofertilizer X. On the other hand, we have the control group wherein the biofertilizer X is not sprayed. So meaning to say it is not applied in our control group. We are just going to apply the normal or the typical fertilizer on this plant. But making sure that both plants are the same, the type of soil are the same, only the independent variable, which is the kind of fertilizer, is being manipulated. On our experimental group, it is the biofertilizer X. On our control group, the typical setup. So a good control group is identical to the experimental group in all way, except for the difference in the experimental condition. Here, we apply the biofertilizer X. On the other hand, we don't apply it to the plant. Now, I will show you a video, and what I want you to do is to identify which one is the experimental and which one is the control group. So, disclaimer, this is an advertisement of a very famous soap, no? Okay, so based on the video that you just watched, which one is the control and which one is the experimental group? So to answer our question, obviously, our control group is the brand X. That is the reason why the brand X is our control group, because that is the typical the typical soap that we use, no, in washing our clothes. So brand X. So that is the reason why for every commercial there is brand X. Brand X is our control group and it is used for comparison purposes. And obviously, our experimental group is the Tide, no, the Tide. So because that is being tested, that is what we are going to use for our experimentation to compare it if it is more effective than the control group, which is the brand X. Okay, so those are the two experimental groups or the two subgroups in conducting our experiment. So in conducting an experiment, that is where you test your hypothesis and make sure that before you conduct an experiment, you have the experimental group where you will apply the variable and a control group, which is the normal setup, so that we can compare them from one another and see which one is better. Now, do you still have any question about the topic? Write them down and ask them during our synchronous session. Thank you for listening and see you on next lesson.